Hello everyone, welcome to the lecture series of blockchain technology and myself M.Naveenraj, Assistant Professor, Department of CSE IoT. In today's topic we are going to discuss about basic cryptographic techniques. So normally the cryptography is one of the technique which is used inside the blockchain technology. That's why we are here to discuss about the cryptographic techniques here. So cryptography is the foundation of blockchain security. It ensures that their data is encrypted, transactions are verified, the records are normally immutable, that cannot be changed. So without cryptography, there is no blockchain, that is not secure. Blockchain is not secure. The basic core principles of cryptography are confidentiality. So only authorized users can read the data, right? Similarly, integrity. So data cannot be altered without detection. And similarly, and third one is authentications. So this confirms identity of sender who sends this message, because these three techniques are very important. And one more thing is non-repudiations. The sender cannot deny the transaction. Okay, so these are the four core principles of cryptography, such as confidentiality, integrity, authentication, and non-repudiations. Then coming into the detailed cryptography techniques such as hash function. A hash function converts input into a fixed length output. Okay, input whatever the data which is received for this hash function, which converts into a fixed length output. Okay, the basic properties of this hash functions are deterministic, okay, so fast computation, collision resistant, avalanche effect. So these are the various properties of hash functions. Okay, so in blockchain, each block contains a current hash as well as the previous block hash. This creates a chain. Okay, that is linked structure. Similarly, so coming into the digital signature, so we have used this digital signature for authentication plus integrity purpose. Okay, so based on the public key cryptography and similar mathematical algorithms, so these will be used for the digital signature process. Okay, the various steps involved in this are: user creates transaction first, then the hash of the transaction will be generated. Once the hash of the transaction is generated, it will be encrypted using private key. Then the final step, that is fourth step, the signature is created. This is how the steps will be followed for creating a digital signature for anyone. On the receiver side, so the user uses public key to verify. If data changes, the signature becomes invalid. Okay, so this is what the great example of this digital signature. Similarly, the public key cryptography bridges between cryptography and blockchain, which is used for wallet address, secure communications, and everything. Okay, so in the structure, we will have some Merkle tree. So that is for bottom, we will use the transaction process, and in the above hash pairs, then top with the root hash value. Why we are using this structure means in order for efficient verification and which saves memory. Okay, example, 1000 transactions happen means only a root hash need to be verified. Okay, you no need to verify all the 1000 nodes one by one, right? Similarly, which is very efficient verification process. That's why we are using this Merkle tree for our verification. So we all know that consensus mechanism, which ensures the agreement among the nodes. Okay, there are two types of consensus mechanisms are POW, that is proof of work, and proof of stake. Example, Bitcoin miners solve puzzles which will validate the block, right? Similarly, the real world applications are cryptocurrency wallets, okay, so Aadhaar verification, secure voting system, digital certificates, banking security. Similarly, these are the various real world applications, and advantages are similar thing like high security, it's a tamper proof, trustless system, and transparency. Okay, Like we have disadvantages also, that is high computational cost and complex algorithms. It requires a key management. Okay. Similarly, you can create some practical scenario, that is for online banking login. That password will be hashed, OTP will be encrypted, the session will be secured. Thank you.